Dr. Stephanie Venn-Watson, I am super curious about nutrient deficiencies because if you think nutrient deficiency on the surface, it seems like, oh, I'm not getting enough vitamin K or I'm not getting enough salad or this and that. But we're actually starting to have more nutritional deficiencies in today's day and age than we have in a long, long time. Can you kind of explain what a nutritional deficiency really is? Because maybe it's not what people think.
Right, absolutely. So Thomas, when we talk about nutritional deficiencies, like you say, a lot of people think about developing countries and, that this is something that's not going to impact people in developed countries, with us. And what we're seeing is basically a new golden age, unfortunately, of nutritional deficiencies.
After today's video, if you usually use omega-3s, I encourage you to check out something called Fatty 15. Fatty 15 is a unique C15 fat that actually has been demonstrated in studies to be 3 times more powerful than omega-3s, especially when it comes down to cellular membranes and actually protecting the cell. So Fatty 15, you've probably seen it floating around. People have been talking about it for quite a while, but the only ingredient in this compound is literally C15 fats. So fats are measured by their carbon chains. So in this case, C15 means a 15 carbon chain fat. One of the most important things that it can do is it seems to repair actual damage to the cells. So it can improve your mitochondrial function. So people take omega-3s because they want mitochondrial health. They want cellular health. They want to support that membrane fluidity. But if you look at the literature and you look at the data, a lot of people, arguably most people, are deficient in the C15 fat, which is a very stable, oxidation-resistant fat. So the problem with fish oil, which, trust me, I am a fan of fish oil. I like omega-3s, but I like getting it from food whenever I can, like sardines and whatnot. The problem with omega-3s, they go rancid because they're prone to oxidation. Fatty 15 is in a powder form, and it is naturally oxidation resistant. So it's not going to oxidize. You're getting a very pure, if not one of the purest kinds of fats that you can get. So much so that literally the only ingredient in a capsule is Fatty 15, C15 fat. So the link down below, Fatty 15/Thomas, is a 15% off discount link, but you have to use the code Thomas at checkout to get that 15% off discount link. It is something that you will probably start to notice pretty quick. Definitely, when it comes down to cellular benefits, it's got the leg up on omega-3s.
So when we talk about what that is, it's basically anytime we have an essential nutrient that our bodies must have in order to maintain baseline physiological health, but our body can't make enough of. So if we don't get enough from our diet, if we don't get enough nutrition of those nutrients, then when it's a true deficiency, it means that we have such low levels that it actually causes clinical disease. So things like we know about like vitamin C and scurvy and pirates and vitamin D and rickets. So that's the definition of nutritional deficiencies. And like you said, we're starting to see more and more evidence of that in our own world.
For sure. Yeah, we've noticed that, at least in the research that I've been looking at and I've talked about, it's like we're closer to vitamin C deficiencies now than we ever really have been prior or after, at least, sailing across the ocean.
It's crazy.
Which is kind of scary to think, right? Because you don't think like, scurvy, like I'm going to, be a pirate. But I don't know if we're getting close to scurvy per se, but these nutrients that we cannot create, our diets are so processed and devoid of nutrients that we could actually be getting ourselves there is kind of a scary thought.
Yeah, we're definitely heading in the wrong direction, right? So when we look at these, nutritional deficiencies, a big question is why is this happening? And there are 3 main reasons that we're seeing more nutritional deficiencies in populations. And the first is, as vegan populations, as they increase, you go on the vegan diet, there are certain nutrients, things like vitamin B12, that we can only really get from animal products, so from meat and cheese, eggs, dairy. And so we can't get those from vegetables. So they need to find a way to supplement themselves to get vitamin B12. When we get older, we don't absorb nutrients as well as when we were younger. So we're getting older, which is a great success story. But what's happening is we have more older populations. We're not really absorbing the nutrients, and that's causing nutritional deficiencies. And the last, which we kind of chatted about, is, Ozempic. So as more people go, we have now millions and millions of people on a drug that's used to decrease weight, which is great. But the way that weight is decreased is you don't want to eat. Yeah. So if you don't eat, you're not going to get, not only do you not get the caloric foods, you're also not getting the nutrients.
Well, you discovered something that was pretty interesting that I want to dive into, and it's a type of nutrient deficiency that people are probably not familiar with. Like when you look at fats or essential fatty acids, and you think, okay, well, I eat enough fat, I'm probably not going to be deficient in a fat. Yeah. You discovered something that's pretty interesting surrounding the world of like a 15 carbon chain fat that we actually need as humans. And that's one of the reasons why I wanted to bring you on, was to sort of talk about this. So can you talk about like how this was discovered, how people can get it, just what it is in general?
Sure. And I love the fact that you said dive into it, because it's dolphins, the discovery.
That's true. That's true.
So timely. So with regards to the discovery of this 15 carbon chain fat called C15 or pentadecanoic acid, the whole discovery, Thomas, of this as an essential fatty acid, the first to be discovered in over 90 years since omega-3, was really, to be honest, it was an accident. Really? So some of the best discoveries, happen when you're not looking for them. So I am a veterinary epidemiologist. I was working for CDC, World Health Organization, and then about 20 years ago, I was brought on by the Navy to help understand and help older dolphins live longer, healthier lives. And so the Navy has a marine mammal program. They've been caring for dolphins for over 60 years. They live in the open ocean, go out into the open ocean every day. Every day they choose to come back. It's pretty incredible. You're familiar with the military, well familiar with the military community. So the Navy takes such a good care of the dolphins, Thomas, that they're living longer than dolphins in the wild. So the average dolphin in the wild lives to about 20 years old. Dolphins at the Navy are living 40 and even into their 50s.
Do you ever have a dolphin that just decides not to come back? Like electively? Like not because
right.
something terrible happens, but they're just like, no.
Amazingly, they've never lost a dolphin due to I think I'm ready to get out of the military. We have had, the Navy has had an example where when they're out and about, where wild dolphins try to take some of the younger females away. But wonderfully, the dolphins can actually jump up in a boat. And so the females will jump up in the boat and say, take me home. These guys are a little too aggressive out here. It's really the only reason the program has worked, because the dolphins really see it as their home base. And they say they get great care. So they get really good care. They live longer. And that got to where we started understanding that as dolphins get older, they age a lot like us. So they can develop high cholesterol, chronic inflammation, fatty liver disease, even Alzheimer's. So it really became a fascinating population. For me, it was reaching out to experts in aging-associated diseases and longevity and saying, hey, what are you doing for people for fatty liver disease, for Alzheimer's? And then they would come back, Thomas, and they're like, what? Like, you have dolphins get these diseases, and when they looked at the tissues, it's the exact same disease, exact same fatty liver disease, exact same, brain changes with Alzheimer's. So it became a mutual symbiotic relationship with scientists working on the human health side, because they're helping us help dolphins, and in return, dolphins ended up helping us in part with the discovery of C15.
So how is C15 itself actually discovered? I mean, it's something like, okay, we were putting XYZ foods in the diet and we noticed that serum levels of this were improving. I mean, how did you stumble across it?
Right. So the first thing we noticed, which was really important, is that the dolphins at the Navy were not aging equally. So despite the fact they're getting pretty much the same diet and they have the same health care, live in the same environment, some dolphins were getting metabolic syndrome, fatty liver disease, insulin resistance, while others were not. So what we did then is we used an advanced technology called metabolomics to look at thousands of small molecules that are present both in the dolphin's blood as well as in their fish-based diets. And we said, hey, which molecules predict the healthiest aging dolphins? And we thought for sure it was going to be omega-3s because all they eat are fish. So it was kind of a common sense thing. And omega-3s didn't even make the list.
Really?
And instead, C15, this odd chain saturated fat, was the top predictor of healthy aging dolphins. So it was like, what's happening here? So that's when we took C15, moved it into the lab to be able to understand, what this molecule does.
So what does a deficiency in C15 look like in a dolphin? I mean, is it obviously increasing the risk of fatty liver, so it sounds very similar to just poor mitochondrial function in a human.
Yeah.
I don't know if that translates over to the dolphin side or not.
It does. So exactly that. So at the same time that we're seeing fatty liver disease, metabolic syndrome, almost everything you just said, type 2 diabetes, heart disease, even cancer is increasing especially among younger and younger people. We were seeing the same trend happening in dolphins, except for cancer. Interestingly, dolphins, for the most part, do not get cancer. So that's another that hopefully somebody pursues down the road here. But they were getting fatty liver disease, metabolic syndrome, insulin resistance, this thing called dysmetabolic iron overload syndrome, or DIOS, which is now recognized as increasingly prevalent in people too. It's all tied, right? It's all kind of the same group of diseases. So this disease was increasing in dolphins, the prevalence in the population, and interestingly, it coincided with the Navy used to use fish with the dolphins that were called candlefish, and they were caught off the West Coast, and they were so high in fat that you could put a wick in them and burn them like a candle. And that's why they were called candlefish. The fisheries back in 1960s, 1980s, and then through the 90s, the fisheries were so aggressive for other purposes for these fish that they got overfished and they disappeared. So the Navy then had to move from this heavy, high-fat fish to relatively low-fat fish. So they accidentally created a diet for the dolphins that, even though they were all fish, were lower in fat, and ends up creating nutritional C15 deficiencies, which, of course, none of us knew about until we made this discovery. So that's the deficiency syndrome we were starting to see hints of in dolphins.
Now, people might look at this and they're going to say, okay, well, this is dolphins.
Right.
How does this translate to humans? How does it translate to humans?
Yeah, so interestingly, at the same time, that we were making these discoveries in dolphins, papers started popping up on the human side, right? In independent groups from us, showing that people with higher C15 lower risk of type 2 diabetes, heart disease, fatty liver disease. And these are giant studies, even at this point now, meta-analyses, so studies of large studies showing that high C15 predicts lower risk of these same conditions. So it's like, this is happening at the same time. When we look at where C15 comes for humans, our main source of C15 is not fish, it's dairy fat. And so we think, okay, so what we accidentally did with the dolphins, we've done, intentionally with humans with regard to decreasing our intake of dairy fat. Yep. So once we moved C15 to the lab, we wanted to move from association to causation. And really from there, all the studies moving forward, Thomas, were focused, of course, to continue to help the dolphins, but really is the same situation happening in humans and getting it tied to the relevance in us. So
what kind of research has come out on the human side, whether in vitro or in vivo? I mean, I'm curious, what we're starting to see.
A lot. So what's good is that, a lot of studies on fatty acids have been done, even looking retrospectively. And in the past, a lot of scientists didn't really focus on C15 because it's present at such low levels in our body compared to other fatty acids. It just kind of got written off. There's so little, it can't be relevant. So once people started seeing the science around C15 in 2020, we published a paper in Scientific Reports. The lead author was Dr. Ed Dennis, who's a leader in fatty acids, editor of the Journal for Lipid Research for 15 years. And in that paper, we did 8 studies over 3 years to figure exactly that. What does C15 do? Is it inactive? And we were able to show that C15 is not just an active and beneficial saturated fat, but that it was meeting these rare criteria of being an essential fatty acid, which means, what we've talked about, a nutrient that our bodies must have, or we suffer. So we're able to do those studies to figure out how it works at the cellular level. So studies being done, we've shown C15, you'll be excited to hear, repairs mitochondrial function. And it does that in part by using this rescue function in the mitochondria, so that even if the first part of energy production in mitochondria is broken, it can skip the line and go to this second stage. So in that way, it's truly rescuing mitochondrial function. It has a really cool, super basic, we love simple, right? We love something that is like just nature did its job and had a simple solution. C15 is a sturdy, saturated fat, so it has no double bonds, which means it's super resistant to oxidative stress. So it's a hardy fat that goes into our cell membrane, and it behaves like a brick in our cell membranes, and it literally stabilizes our cell membranes. There's this really cool theory by A.J. Holbert. It's called the cell membrane pacemaker theory of aging. And he showed the sturdier the fats in our cell membranes, the longer as a mammal we live. So explains how humans and dolphins live longer than mice. And so here we have C15, this stable saturated fat, feeding right into that hypothesis. And then it also activates longevity signals. C15 activates AMPK. It inhibits mTOR. So it plays in, it's truly a promiscuous molecule that knows to do a lot of good things. Nature did its job.
So I guess, by definition, obviously by its carbon length, it's considered a saturated fat. But what differentiates it from, something like a C22 or all the way up, the carbon chain to these other saturated fats that people might be saying, oh, well, saturated fats are problematic. Like which I know is debatable to begin with, but like what's the difference there?
Well, where the science seems to be landing, and we're continuing to learn, is it's becoming pretty clear that there's a big split between saturated fats, or whether they have an even number of carbons or an odd number.
Really?
Yeah. So the odd numbers, C15, C17, anti-inflammatory, are pro-insulin signaling, have all of these benefits I just talked about. The even chain saturated fats, like C16, C18, they are, especially those two, are pro-inflammatory. I mean, they're used by scientists all the time to induce inflammation. Higher levels of C16, C18 associated with a higher risk, type 2 diabetes, heart disease. So it's incredible thinking how nature, like what the difference that one carbon can make, which is why this really didn't get discovered, because the assumption is it really going to be that much of a difference between a C15 and C16? So, but now there's really indisputable science showing that there is, in fact, this division, and that we need the C15 and then the C17 it makes, and we need less of the C16 and 18, this pro-inflammatory.
That's so
fats.
wild.
It's crazy.
I mean, it's cool because over the last 5 years, with, I guess, more interest in the ketogenic diet, people started understanding. Well, when they look at, for example, MCT oil, they know, if they're interested in that world, that there's such a dramatic difference between even a C8 and a C10, or especially between a C8 and a C9, right? When you're talking MCTs. But before, I'd say 2015, I could just kind of say a rough random date. People would, a fat is a fat is a fat. Maybe if they're well versed, they'll say, okay, a poly, a mono, and a saturated. That's it. But I've almost compared it to, we look at carbohydrates with a glycemic scale. Why don't we look at fats that way? Why don't we, not that it's the same. And I mean, from an energy dynamic standpoint, perhaps there is some similarities as far as how quickly they're absorbed or whatever. But it's just interesting that we don't look at it like that. It's still common theme to group all saturated fats with saturated fats and group all polys with polys and monos with monos, despite complete differences between them, not to mention, antioxidant abilities and whatnot. So what about digestion with C15? Because I'm kind of curious with this. Like, is it chylomicron related? Is it like more like an MCT that can just go directly into the portal vein? How does it work?
Yeah, so it's, and you're spot on with all of those comments, by the way, with regard to fat, it's a fat. And so it's great to be able to educate more and more people as we learn. I mean, we're really just moving along as the science is advancing. For absorption of C15, the nice thing is C15, when it's in the free fatty acid form, is readily absorbed. And when you look at C15 in food, whether it's in an oil, plant oil, which is present in really low levels, or in dairy fats, which is a little bit higher levels, it's always in a triacylglyceride form. So C15 is always kind of like your MCTs. It's always, there's a triglyceride branch, and then there's 3 different fatty acids attached to it, which makes it a triglyceride. One or any of those could be a C15. But when we eat those, because they're longer chain, those aren't absorbable. So it requires us to have digestive enzymes to basically pluck off those free fatty acids, the C15, make it a free fatty acid. And once it's there, then it's readily absorbed, and it goes into our bodies, and it gets incorporated in many different types of lipid species, which really allows C15 to do a lot of good things throughout the entire body.
Is there, we went back 100 years, because obviously we're starting to become more deficient in this now with how our diet's changed. Can you speculate that 100, 200 years ago, we were just consuming more dairy, or are there things in our diet today that offset the absorption of C15, and that's what the problem is? Because that's what I want to understand is, okay, or is it something that, there's these things that we always understand or discover that maybe, if we knew this 200 years ago, maybe people would have lived a lot longer, and we're kind of understanding almost you can almost call it, maybe not ergogenic, but just an additional benefit, right? Like that we just didn't have hundreds of years ago. That's
a great question. So on one hand, back in the day where we had milk straight from cows, and it's understood that C15 was at high levels, and people were in certain countries, right, eating plenty of dairy to be able to get their adequate C15 levels, when we didn't have type 2 diabetes and obesity and fatty liver disease. Then if we fast forward to today, the question is, well, gosh, if this is happening simply because we've decreased our intake of dairy fat, can we just go back to eating more dairy fat? And for kids, that may still be true, but what we're really understanding is, to your second point, Thomas, is that our food has changed. We know that even whole fat dairy milk today has less C15 than it had before, and that's because of influences of things like, if a cow eats corn, it has less C15 in its milk than if it eats grass. Certain breeds of cows have higher C15 than other breeds of cows. And so there's more and more diversity and I'd say threats to C15 levels in our foods. So we may not be getting the C15 we're getting even if we went back to drinking whole fat milk. But it could be a good start, right, to at least try to... the cycle has gotten worse over time because generation over generation are increasingly avoiding dairy fat. And so and then when moms are low in C15, they're passing that on to their babies. And studies showing that infants who nurse off of moms that have low C15 have lower body growth, lower brain development. So it's really something that, we want to get ahead of and as soon as possible.
Yeah. Is there any literature that demonstrates like different regions of the world, or are we not there yet, that have lower levels of C15 or higher levels of C15? I would imagine maybe countries like Russia that consume a lot more dairy maybe are a little bit higher? I mean, is there any of that out there yet?
It's a great question. Yeah, you're exactly right. We're not there yet, but more and more countries are focusing on C15 now and starting to look at it. There does seem to be a common trend of decreasing C15. For Western countries, it's primarily because of dairy fat, but also as we get older, same thing was with vitamin B12. We don't absorb C15. We think it's because absorbed, but our C15 levels go down as we age, even with the same diet. And in Eastern countries, interestingly, it appears that could be because of they're eating less fish, which is obviously dolphins weren't getting their C15 from ice cream.
Yeah,
so Eastern countries kind of are going through that same trend where fish used to be part of 2 to 3 meals a day, and it was the whole fish. And now, diets have moved away from that. So we're seeing common trends across, which we think is why it's starting to drive this increase in type 2 diabetes, heart disease, cancer, and the hypothesis that fatty liver disease, which kind of showed up out of nowhere right now, affecting 1 in 3 people globally, 1 in 10 children, fatty liver disease, the hypothesis that's being pursued that nutritional C15 deficiencies is fatty liver disease. So
interesting. And then, because fatty liver in some ways is almost a proxy for visceral fat in the first place, and sometimes, or vice versa. It depends who you ask, like chicken or the egg kind of thing. So, could you speculate that C15 is a big driver for visceral adiposity in the first place? Or is that something that you guys are looking at?
It's something we're looking at. We're really focused on the primary source being the liver, because dolphins were kind of a source of that. So we were seeing in dolphins a primary fat deposition in the liver, and Thomas obviously recognizing there are going to be different phenotypes of fatty liver disease, so that the ones where it's primarily starting in the liver and then rolls over, so then the liver stops working as well, sets up insulin resistance, and then everything else falls behind that. But yeah, that a study was done by Jeff Schwimmer, Rady Children's Hospital. He opened the first fatty liver disease clinic in the world. And when we had published that dolphins had fatty liver disease, it was back in 2012, maybe, he reached out to us and he's like, no way. He's like, dolphins don't get fatty liver disease. I think it's something different. So send me liver tissues. So we sent him slides of a variety of, 20 different dolphin livers that we had in the archives. And he sent an email back and he's like, we are a go. This is the exact same disease. So he's like, it's clearly not sugar in dolphins. Yeah. What's going on? So fast forward to today, 10 years later, Jeff published a paper a couple years ago showing that the higher the amount of C15 in children in their blood, the lower it's inversely related to the fat in their liver.
Wow.
And then he just finished a clinical trial with C15 supplementation among his young adult patients. Stay tuned. We can't talk about the results, but those will be out later this year.
We're seeing fatty liver literally in pediatrics and adolescents, like in kids.
Oh, it's crazy. It's like 1 out of 10 children have liver. Yeah, it's super scary. And what's really difficult is it's a very aggressive state. We still don't have an official treatment except for your great recommendations of exercise and weight loss, right? Yeah. So it's that those still help, but and it's on fire. It's like the papers can't get published fast enough showing the prevalence before, the first last paper that was published 2 years ago, it was 1 in 4 people. Paper published last year is now 1 in 3 people. It's super scary how fast, it's like a fire, and our bodies have become kindling for it. And we think it's in part because of this, lack of C15.
Yeah. Is this potentially independent of obesity as well?
Independent of obesity. And we're seeing more people who are not obese and have fatty liver disease. And in fact, those people have the most aggressive forms of NAFLD, the fatty liver disease, that then rapidly progress to non-alcoholic steatohepatitis or NASH. And then that leads to liver cancer, liver fibrosis. It's really, and so when we talk with Jeff, with Dr. Schwimmer, he is like, we cannot find a solution fast enough. He's like, it is getting worse and worse. The number of patients he has coming in, children he has coming into his clinic, it's it's frightening him. So it's definitely, a top priority on our questions.
Is it manifesting in symptoms related to insulin resistance in these kids? Is that how it's becoming like aware? Hey, like my kid's eating this and his blood sugar goes up, or he went in for a check. I mean, is that how it's originally getting discovered? Because it's so weird in kids. It's so difficult. Like it's so hard you don't have that repository of like life experience that's like, hey, like I'm feeling really weird after I eat sugar. Maybe I should check my blood sugar. With kids, it's, it can be difficult. So I'm curious how this is coming up in the first place.
Yeah, I mean, it's terrible how it's all coming up. It's as we're seeing more and more kids are getting aging-related diseases. And so the way Jeff characterizes it is that children are getting the aging-associated diseases of their grandparents before their parents. So the way he's seeing it is he says absolutely the whole picture, it's all appearing to be accelerated aging. So we have children that are aging faster than they should. And so they're picking up things, not just, signs of insulin resistance, but they're having hypertension, they have high cholesterol, and a lot of it is associated with obesity, but it's what's feeding what in this whole situation.
Yeah, and I get curious about, because you have one camp that'll say that this can only happen in a state of overnutrition. Mm-hmm. And it almost seems as though like maybe there's other pieces, which I mean, again, a nutrient deficiency would make sense there. That would be the overnutrition piece makes sense. And I'm 99.9% sure there is a strong piece there, right? I mean, if you overeat a lot of sugar and fat, you're probably going to have a metabolic problem. Right. But I could see how when there's one massive deficiency, how everything just gets cattywampus.
Yeah, that's right. It's like, we're energy rich, nutrient deplete. Yeah. So it's this whole idea. And there have been a couple of really interesting studies showing, and they're in mice, so they're early, but that when you feed a mouse a high-fat diet, their C15, which has C15 in it, by the way, their C15 levels go down. And one follow-up study to that showed that the high-fat diet influenced microbes in the gut, because it's hard to have any conversation without the microbiome, gut microbiome, that it decreased bacteria in the gut that help grow and produce some levels of odd-chain saturated fatty acids. So to your point, the overnutrition not only is driving these things, but it could be causing malnutrition and nutritional deficiencies, for things like especially C15.
Interesting. I mean, I could be totally wrong because this is not my area of expertise per se, but it's almost as though you only have so much transport mechanism as well. And if the body is going to take something that perhaps is more, I don't know, maybe energy rich or something that seems like preferentially maybe it's going to take other fats, and C15 just kind of gets the short end of the stick. Yeah. I don't know, but who knows? I mean, it's when you start getting into the microbiome and all that, then it's who knows?
Yeah, I mean, and even just from an odd standpoint, right, it makes sense. So if you look at C15, even in dairy fat, so you have dairy fat, 1% of that dairy fat is C15. Over 40% of it is C16 and C18. So even, to your point, Thomas, that if you look at the odds, it's like you're absorbing a whole lot more of these pro-inflammatory, pro-obesity fats and C15. You're just like, it's hard to give it a chance to be able to do what it needs to do.
So is Fatty 15, the product that you formulated, is that literally what you're giving dolphins to? Because I was going to ask, okay, if you can't give dolphins some raw milk or something, it's like, are you supplementing it?
So the Navy started with giving dolphins higher fat. So they went searching for higher fat fish that had C15 in it. And sadly, our oceans are getting warmer. And so it's becoming nearly impossible to find fish that have enough fat that had with C15 in it to be able to meet what they used to get in the wild or at the Navy. So that's answered. So now they're moving towards supplementation with Fatty 15. So Fatty 15. So because C15 was discovered while I was at the Navy, it's a Navy technology, and Eric and I, my Navy physician husband, and I spun off Serafina Therapeutics to then develop in collaboration with the Navy to help bring a pure C15 to the world, with the original goals to develop for the dolphins. And then as we started moving forward and the world started understanding how important and in fact essential C15 is, not just for dolphins but for humans, then we developed our pure C15, free fatty acid, vegan friendly supplement that has just C15 and without the C16 and the bad fats.
How are you able to create a C15 in a vegan form? I'm curious.
Right. So the way that we do it is we take C4, so it's C14 from plants. So
Okay.
plants have lots. C14 is readily available in plants, and then a carbon is added onto it. So
Oh, cool.
it's bioidentical C15 because it's such a simple molecule. It's really easy to be able to basically reintroduce C15 back to our bodies.
Now, I know in the supplement world, it's you don't want to make claims and whatnot, but I'm curious, is this something that, at least from what you've heard and anecdotally, is it something that people can feel pretty quickly? I always joke that it's like difficult to sell insurance, right? It's always like, especially with people,
Prevention.
it's not sexy, right? Like, so I know a lot of demographics that are, say, even under 40. They're like, okay, longevity, cool, but like, will I feel something today? Like, it's a hard question to ask because I know I don't want to put you in a corner, but is that something where, like, if people are deficient in C15, do they notice a difference in how they feel when it's added back into their diet, whether it's supplemental or through enough dairy?
Yeah, no, they do, which was amazing. So as we started bringing Fatty 15 to the world, we launched it in 2021, sold out in 6 weeks, and became Nutritional Outlook Magazine's Ingredient Supplier of the Year award. So gained a lot of attention. While this was happening and Fatty 15 was getting out into people, they were telling us things, Thomas, that the dolphins couldn't tell us, like, I slept really well last night and I'm not hungry between meals and my mood is calm, and it's including from our fellow military and veterans of that. We have one colleague who said there was a pre-Fatty 15 me and there's a post-Fatty 15 me, and like the family loves the post-Fatty 15 me. So we were curious because we thought, is this a placebo effect? And really, and then we were feeling the same benefits. So we then, the science has continued over the last 3-4 years. And when we went back to the dolphins, we actually discovered a second molecule called pentadecanoyl carnitine, a mouthful, so I'm just going to say PDC.
Okay.
And it's a metabolite of C15. So our bodies take C15, attaches a carnitine to it, and makes PDC. And when we tested PDC in the lab, completely unexpectedly, it ended up being the second ever discovered full-acting endocannabinoid, fully activating CB1 and CB2.
Holy
and we're
cow.
like,
That's
that
the calm. Yeah.
Got it. Sleep, calm, pain. A lot of people saying that it is helping with their joint pain. I myself was going through menopause and the joint pain had kicked in. I was getting tennis elbow without playing tennis, and Fatty 15 fixed it. So it all gets down to speaking to, I think, the essentiality of C15. It truly is. We truly are lacking enough of it. In its pure bioavailable form, it's able to have its efficacy not only in its direct long-term effects, because we get people coming in and talking about it's lowering my blood sugar, my cholesterol is lower. There's a clinical trial that just came out with C15 supplementation from Singapore that showed it effectively lowered cholesterol, improved the gut microbiome, and decreased the amount of abdominal fat. So feeling better was a delight and surprise, and to be honest, it's why we have over a 95% monthly retention rate, which is like unheard of in supplements. And it's to your whole point, like, I feel better. Yeah,
no, I mean, you guys are highly, highly credible in the research community as well, which in the world that I kind of swim in and play in, there's not a lot of supplements that get talked about in high regard. Like supplements, it's sketchy territory for a lot, right? It's a lot of I know you're not selling snake oil, you're selling dolphin oil, but and back to the endocannabinoid thing really quick. It's kind of interesting because people will say, well, I don't want to be acting like I'm taking CBD or whatever. I don't think what people realize is that we have endocannabinoid receptors for a reason.
Exactly.
They're supposed to be occupied or activated by certain things. And it's becoming more and more clear that the only time people are getting the activation to the point where they feel it is when they take a foreign substance. And they're not realizing that, like, maybe, just maybe, and this is purely speculative because I don't want to, say anything causes anything, but the rate of anxiousness and kind of anxiety is more deficiency related than maybe the counter what people might think. I mean, yes, we have a lot more on our plates. We have a lot more in today's world for sure, and a lot of things that would trigger anxiety. But it almost seems as though, okay, maybe we don't have as much quote unquote like natural activation of these endocannabinoid receptors as we did in a properly balanced diet.
Yeah, spot on. And so that's the direction we've been heading with this, with this metabolite of what happens if we have nutritional C15 deficiencies, which then translates to lower levels of PDC. And like you said, we have all of these wonderful receptors that are there not for cannabis. It's there to be the ultimate homeostatic hammocks, basically just waiting to be activated so that our body and mind can be balanced and feel good, so that we can live long, happy lives. And so what is supposed to be triggering it? There's only been one other full-acting endocannabinoid, and it's made from another fatty acid, which is omega-6, arachidonic acid. Yeah. So it makes sense that C15 makes this metabolite, and just saying, gosh, just get it back into our bodies so that we can fix, like you said, these sleep disorders and anxiety and depression may in fact be increasing because of nutritional deficiencies. Obviously we're focusing on C15.
This may be something you do or don't know. I don't know. But there's been talk of like omega-6s potentially, like omega-6s, like going with, further down the chain, increasing appetite because of their effect on the endocannabinoid receptors. But you mentioned some anecdotal experiences of people having, hey, like my appetite is decreased. So I don't know because I'm not well versed. And I know Berkeley's published a lot of like endocannabinoid research. I can't remember the researcher out of Berkeley that's publishes a lot of that. But I think it can go both ways, right? So people think, okay, cannabis, that's going to make you want to eat more.
Right, Dorito, or I didn't just endorse anything.
Yeah. What's that?
I was like, chips. I was eating chips. I didn't want to endorse a product.
Talk about Doritos all you want. There's a lot more going on than just seed oils and those things. So, but you've heard people when they're utilizing fatty 15 or getting more C15 in their diet that their appetite is suppressed. So does it seem to work the other way as well?
Just because of that observation, it does seem to be the case. I mean, we do know that, again, showing that C15 is promiscuous. It also activates PPAR alpha, which is known to, if you activate PPAR alpha, that can suppress the vagal nerve, which then decreases your desire for food between meals. So it may be that it's counteracting itself, but it certainly isn't doing the traditional effect that we're used to associating with cannabis and getting the munchies, and people seeing the opposite, which is really interesting.
That's so interesting because that could be exceptionally cool for people that are doing keto or fasting, just simply because there's a natural activation of PPAR alpha and the nuclear receptor protein in the first place. So if you can kind of influence or increase the activation of that, because that's the catalyst for so many different effects of fat adaptation that happen when subjects are fasting. Do dolphins they have that same nuclear receptor protein? Because I would imagine they go long periods of time without feeding, and then they kind of go, because they don't, or do they graze all day? I don't know. I have no idea about dolphins.
It's such a good question. So back in, 2005, I think we were talking about it. We went on NPR Science Friday to talk about this exact question, because we were seeing that dolphins were developing a diabetic-like state if you follow their glucose levels, but they weren't developing what we would know as diabetes. This is before we knew about the metabolic syndrome component, and so, but it just not. They've never had a flat-out, this dolphin has type 2 diabetes, but you would see these increases in glucose happen in insulin that was mimicking people with insulin resistance or type 2 diabetes. And there are dolphins that are grazers, the ones that are close to shore. They'll sit and they'll snack all day long. Or it'll be the other extreme, the deep water ones. They'll eat a bunch and then fast for a long time. So dolphins are adapted to do either of these things. And the hypothesis is that dolphins used to be land animals. Well, we know that. Dolphins used to be on land. They decided, I'm going to go back into the water. They had these big brains. And once they went back into the water, they went into like basically a ketogenic diet. They left the carbs behind. They went all protein diet, all protein and fat. And when they did that, the hypothesis is they actually developed insulin resistance as a way to get their body to make glucose that their big brains needed. And so for dolphins, insulin resistance is actually a positive state.
Yeah, it's a peripheral insulin resistance versus pathological.
There's no reintroduction. Like same thing, hypothesis for us with the Ice Age, that when we moved to the Ice Age, carbs were gone. We may have then evolved to have insulin resistance to adapt to that world. But then the carbs came back, and that we didn't handle that so well.
That's so fascinating. Yeah, because I mean, I didn't realize that dolphins had gluconeogenesis just like humans. I mean, that's so wild. I mean, so they're literally, okay, you've got a brain that has a huge glucose demand. Clearly, they're not, I don't think that mackerel have, high amounts of sugar in them. I don't think there's ocean pixie sticks. I don't know. I've never broken open coral. But yeah, that would make complete sense. So you develop a form of insulin resistance. We were talking before we were filming, they've started noticing this even with bears during hibernation, that bears become insulin resistant. And at first they're saying, well, what's going on with these bears? And then they're realizing, like, oh, they have like a weird chronobiology that when they start going into hibernation, they have increases in PPAR, and they have these increases that start making them become more insulin resistant, so that they don't need to be eating and they can essentially run off their fat more efficiently while they're sleeping.
Exactly. Yeah, exactly. Same thing. So it's just like, we just did it as humans too. It's just like, whoops. It's like, we just didn't realize the ice was going to melt. And we just carried that insulin resistance with us in, a brave new world of carbs.
Yeah. And abundance and lots and lots.
That's right.
So, Stephanie, where can everyone find Fatty 15? Where can they find more about your research and what you're doing as well?
Sure. So you can go to fatty15.com, and that's where you can read all about Fatty 15 and the product and information, testimonials, science. And then we keep all the science, all the peer-reviewed publications, ours, but also now many, many others. Probably every 1 to 3 weeks, there's a new paper on C15 being published throughout the world. So we keep all of those at discoverc15.com. And if you go there, then you can read all the science, and that also could maybe help you fall asleep. It's a lot.
I have heard people say that about my videos a lot. They literally, they say that. I mean, it's nothing, no malice or anything towards me. They're just like, your voice talking biochemistry puts me to sleep. It's what I used. So
there you go, spreading the wealth of goodness. Love it.
Cool. Well, we'll also link a 15% off discount link down below for Fatty 15 as well. And Stephanie, thank you so much.
Thomas, it's been a pleasure. So nice.